Today's topic is going to be RAID 0 and RAID 1. This is sponsored by Hitachi, so a big thanks to them for providing the drives we're going to use today. We're going to be covering RAID 0 and RAID 1 because these are the two levels of RAID that are going to be most practical for an everyday consumer. In short, if you don't feel like watching the whole video, RAID 0 gives you dramatically better performance, but at reduced reliability, and RAID 1 gives you double the reliability, but no increase in performance and a significant increase in cost. For no reason other than sheer numerical order, we're going to start with RAID 0. The way RAID 0 works is you take two drives, so it's a bit of a stretch to call it RAID at all, truthfully, because RAID does stand for Redundant Array of Inexpensive Disks. And while we do have an array of disks, it's not redundant. The way RAID 0 works is you actually take each bit of data and you write alternating between the two drives. So hopefully that's enough of a demonstration and I don't have to actually draw all the arrows for you. But if this was a sequence of data that the computer needed to write to your drive, it's going to write the 0 here, the first one there, the second one here, the second 0 over there. So what happens is effectively half of your data is stored on each drive. This gives you a performance boost whenever you're reading or writing large files to and from your drive, so it's great for video editing. But the disadvantage is if one of your drives dies, you're only left with half of your data. But it gets worse. The half of the data doesn't work like this because it's every alternating bit, so it's not usable data. RAID 0 means you have to buy two drives, so it is slightly more expensive to get set up in the first place. It means that you get much better performance, but you double your chances of losing your data due to a drive failure. Now let's talk about the concept of RAID 1. RAID 1 has a huge practical application to the everyday consumer because unlike higher levels of RAID, you don't need any complicated RAID controllers in order to make RAID 1 work really well. RAID 1 is a true RAID in that you've got redundant storage of your data. So the way it works is we've got the same sequence of data that we wrote to our drives with RAID 0, and we're going to write them to our two drives here with RAID 1 because RAID 1 also operates on a minimum of two drives. So the 0 goes to this drive and this drive. The 1 goes to this drive and this drive, and so on and so forth. So each of these drives actually contains all of your data. Now what that means is that there is zero performance benefit. You might get a slight boost when you're reading from the drives, but in terms of writing data to the drives, since it has to be done to both of them individually at the same time, it works exactly the same as a single drive. But where you run into an advantage with RAID 1 is any data you write is completely safe from hard drive failure. So if this drive goes down, you still have all of your data completely safe. The system gives you a notification, hey, there's been a drive failure, fix it. So all you have to do is you grab a new hard drive, you plunk it in where that one was, you tell the array to rebuild itself, and then this drive, so let's say we're going to add a new drive here to replace the failed one, and this one will automatically copy itself completely over to the new drive. So the only way to actually lose your data if you're running a RAID 1 is to have it corrupted by some software means like a virus, or to have both drives fail at the same time, which is quite unlikely unless you encounter something like a power surge. Now that we've covered the advantages of the two kinds of RAID that I'd really consider practical for average Joe, let's talk a little bit about what you need to get them set up and how to do it. So the first thing I'm going to do is press Control-I to enter the Intel Matrix Storage Manager in this ASUS P55 motherboard. So this motherboard does support RAID. You will need to make sure, first of all, your motherboard supports RAID. The next thing you're going to need to do is ensure you have the correct number of hard drives for whatever RAID level you're trying to do. So that means that if you're doing RAID 0, you'll need anywhere from 2 to 6 hard drives in this motherboard's case. If you're doing RAID 1, you'll need anywhere from 2 to 6 hard drives in even numbers, so 2, 4, or 6. So we're going to configure RAID 0 first of all. So we're going to go to the first option here. We're going to press Enter and create a RAID volume. We're going to name this RAID 0 Hitachi and press Enter. The RAID level, we have a few different options. So we're going to be doing RAID 0. So we can also do RAID 0, RAID 1, RAID 10, or RAID 5. Those two we're not really going to cover today. RAID 0, we're going to select our disks. Press Enter. So here we have a list of all of the drives that are attached to this system right now. I'm going to pick the ones that are on port 0 and port 1, and then I'm going to press Enter. Now, with RAID 0, I can have as many drives striped as I want, but every additional drive I add to the stripe will decrease the reliability exponentially. So bear that in mind if you're creating an enormous RAID 0 array. The next thing we're going to do is we're going to set the strip size. Now, strip size is a bit of a personal thing, actually. The best thing to do is experiment with a few different ones and find out which one works for you. We're going to leave ours on default. A large strip size is good for large reads and writes, such as video editing, where you're working with big files. Capacity, we're going to go for the maximum capacity. So you can see the capacity is exactly 2 times 1 terabyte drives. So we get the full capacity of both drives, we get double the performance, but now, as soon as we create that RAID 0 array, any data we put on there is a little bit less safe. We showed you how to set up RAID 0 in the last shot. Now we're going to show you that the RAID 0 is officially set up. Name RAID 0 Hitachi, RAID 0 stripe, 128 kilobyte strips. This is a 1.8 terabyte volume. Remember that, that's important. And the status is normal, and we can boot to it. So you can actually use RAID to improve the performance of your OS by booting up to a RAID config. Anyway, we're going to delete that volume right now because we don't need it anymore for the sake of this particular video. There it is. It's gone. All of my drives are now configured as non-RAID disks again. And we're going to create a new RAID volume. This time, we're going to do RAID 1 Hitachi. And we are going to select RAID 1 Mirror. So the first thing you're going to notice as soon as we select RAID 1 Mirror and we select the same 2 disks is that the capacity is limited to 931.5 gigabytes. Because, as I explained before, the data is being written to both drives at the same time. So even though we have 2 1 terabyte drives, we only get 1 terabyte capacity. So that makes RAID 1 much more expensive per gigabyte of storage than standalone hard drives or RAID 0, but you get that fail-proof, almost, asterisk, security for your data. So I'm going to go ahead, press Enter, and I'm going to create the volume. Remember, when you create a volume, you will wipe out all the data that exists on the disk. So only use blank drives to create a RAID array. So now we're back into our storage manager, and you can see we have our RAID 1 Hitachi set up. Strip size is not applicable because it's just writing the same stuff to either drive. It's not writing strips to one drive and then the other. And there's our size, the status is normal, and it is bootable. So you can even use RAID 1 to install your OS and make it so that if a drive crashes in the middle of an important paper you're writing, you can just keep working. Because this episode's meant to focus more on the basic levels of RAID that your average person would use, we haven't talked much about it, but we will be doing a follow-up episode, so stay tuned. But we're going to cover things like RAID 5, RAID 6, which are ways to build much larger arrays. So we're not really talking about necessarily 2 disks at that point, but a minimum of 3 or 4 disks. And what those levels of RAID allow you to do is create a much larger array that can actually have any 1 drive fail, or even any 2 drives fail in RAID 6, and then it can actually rebuild that data based on little bits of it stored on all of the other drives. Very cool technology, but what you need for those is a dedicated RAID card in order to get anywhere near half-decent performance. So this is an Adaptec 5445 RAID card. We're going to cover that in more detail, and we're also going to take a closer look at things like external RAID boxes, where you can buy little towers, fill them full of hard drives, and then use that to do all of your RAID calculations, and then you just plug one cable by USB or eSATA or whatever you want into your computer. So thank you for checking out our NCIX Tech Tips today on RAID 1 and RAID 0, and do stay tuned for more episodes on this topic in the future.